This is going to be a video how to calculate probabilities by taking a data point, converting it to a z-value, and then using a standard normal curve to find the probability. So this problem says the Department of Agriculture states that the average cost of food for a 14 to 18-year-old male is $261.50 per month. Assume the monthly food cost for a male is normally distributed with a mean of $261.50 and a standard deviation of $16.25. Use a standard normal curve to find the probability that the monthly food cost for a randomly selected 14 to 18-year-old male is less than $280. So the first thing I'm going to do is I'm going to draw a curve, and I want to remember that my average for this curve is about 261.50. So this is going to be above average. I'm going to put my 280 here. And I want to remember that I want to shade my curve, and this is less than, so I am looking for this portion. Now, my normal curve, my standard normal curve, she doesn't operate just in any data point. I have to find how many standard deviations. I have to find the z-score. Remember, a z is how many standard deviations we are from the average. And we use the formula x minus average divided by standard deviation. That's the same if you've seen it this way. Both of these formulas are exactly the same. So we're going to go 280 minus the average over the standard deviation. And now we're going to grab our calculator. We're going to go 280 minus 261.5 divided by 16.25. And I get a standard deviation of 1.14. I always want to go to two decimal places. Now I'm going to go to my curve, and I'm going to look for that z-value of 1.14. So here's 1.1. And then I'm going to go across to the 4, and here it is right here. And it's, if you can't see it, that's 0.8729. And because the picture I drew looks just like the picture here, like where it's everything to the left, it's everything less than to the left of z, I know the probability that a male spends less than $280 on food is 87.29%. Okay. More than 270. So 270 is still higher than average. So I'm going to draw my curve. I'm just going to put this 270 and higher than 270. And I'm going to follow the same procedure as before. I need to know how many standard deviations this is from the average. Oh, that's bad handwriting. And again, I'm just going to grab my calculator. I'm going to go 270 minus 261.5 divided by 1625, and that's only 0.54. So I now know that this is my z-value. So I'm going to look at 0.54. Here's 0.5. Here's 0.54. So I've gotten the probability of being to the left of 0.54 is 0.7054, which is this amount. Now I want what's higher than that. So what I'm going to do is I'm going to do 1 minus, because the whole curve, remember, adds up to 1. So I'm going to do 1 minus 0.7054, and I get 0.2946, which is 29.46%. All right. Now I want to find the probability that someone spends more than 250. So again, draw my curve. And now 250, now this one's below average. Remember, the average is 261. And I want more than. I don't know why I used lines that time. Just mixing it up. Data point minus average divided by standard deviation. So now I get negative 0.71. So I need to go to the back of my table. I'm going to go to negative 0.71. And can you see? Oh, whoops, I was a little off. 0.71, here it is. Remember 0.7, this is the 0, this is the 1. And I have 2389. So that's actually this area, 0.2389. Because the table always gives me the area to the left. And again, I want the area to the right. 1 minus 0.2389. And that's so that one's going to be 76.11%. So just to do a real quick recap, the first problem we did, we found the z-value, and it was a positive z-value, and I was looking for the area to the left. So I used the front of my table, and I just, whatever number I got on that table, that was it. The second problem, I also got a positive z-value, but I wanted the area to the right. So whatever number I got, I had to subtract it from 1 to get the area to the right, because the table gives the area to the left, and the left plus the right is always 1. More than 250 gave me a negative z-score, so I went to the back of the table, and just like the previous one, I had to subtract it from 1 because I wanted the area to the right. We're going to do one more together, and this is going to be a between. I want between 240 and 275. So I have one number that's above average. Ooh, that's not pretty. That's okay. Here's 240. Here's 275. So we need to find those z-values. This might be a good time to pause the video and try to find these z-values yourself and just make sure that you're like really good at finding z-values. Arrgh! Not right. All right, so the first z-value is negative 1.32. And then the second z-value is 0.83. So I'm looking for, so this is, I'm just going to mark them here. This is negative 1.32, and then this is 0.83. I'm going to go to the negative 1.32 first. So negative 1.32 is going to be 0.0934. Okay, so I wrote that in purple. I don't want this. I'm looking for this area right here, the area between. So I'm going to pause on that. Now I'm going to get the value for 0.83 from my table. And 0.83 is right here at 0.7967. So I know that from here all the way to the left is I already forgot what it was, 7967. So what I need to do is I need to subtract off this purple area. I don't want this area. It's not part of what I'm looking for. So I'm going to go 0.7967 minus 0.0934 because I don't want that. I only want the between area. 67 minus, and I get or 70.33%. And it says to explain the meaning of the probability that I found here, 70.33% is the probability that a male ages 14 to 18 years old is spending between $240 and $275 a month on food. Are you done?